Have you ever imagined your kitchen as a secret laboratory, filled with bubbling potions and magical mixtures? Well, guess what? You don't need fancy beakers or test tubes to become a scientist. With a few everyday ingredients found right in your pantry, you can unlock a world of exciting chemical reactions and become a kitchen chemist extraordinaire. In this adventure, we'll explore 5 fascinating experiments that will make you see ordinary things in a whole new light. Get ready to erupt volcanoes, inflate balloons without blowing, and even create your own dazzling artwork, all using the power of science. Remember, safety is our top priority, so always ask a grown-up for help and follow the instructions carefully. So, put on your scientist hats, grab your ingredients, and let's dive into the fascinating world of kitchen chemistry. Remember that baking soda and vinegar volcano you made in elementary school? It's a classic for a reason. It's simple, it's messy, and it perfectly illustrates a chemical reaction. This time, we'll add a twist with some dish soap to make it extra bubbly. You will need baking soda, vinegar, dish soap, a tall container like a vase or a bottle, a small cup or bowl, and food coloring if you want. Let's get started. Place the tall container in the center of your work area. This will be your volcano. Fill the container about 2/3 full with vinegar. Add a few drops of dish soap to the vinegar. This will create a foamy eruption. If you want a colorful eruption, add a few drops of food coloring to the mixture. In the small cup, mix a spoonful of baking soda with a little bit of water to make a paste. Quickly pour the baking soda mixture into the vinegar-filled container. Watch your volcano erupt. This experiment is a fun way to demonstrate the power of buoyancy and gas release. It's like a tiny dance party in a glass. You will need a clear glass or jar, raisins, and clear carbonated soda like Sprite or 7-Up. Let's get started. Fill the glass with the carbonated soda. Drop a few raisins into the glass. Observe what happens to the raisins. What's happening? The raisins are initially denser than the soda, so they sink to the bottom. However, the carbon dioxide gas in the soda forms tiny bubbles that cling to the rough surface of the raisins. These bubbles act like tiny life jackets, increasing the raisins' buoyancy and causing them to rise to the surface. Once at the surface, some of the bubbles pop, causing the raisins to lose buoyancy and sink again. This creates a continuous cycle of rising and sinking, making the raisins appear to dance. This experiment shows how a chemical reaction can create gas and inflate a balloon without you ever having to blow into it. You will need an empty water bottle, baking soda, vinegar, a balloon, and a funnel if you have one. Let's get started. Carefully pour vinegar into the water bottle until it's about 1/3 full. Using a funnel, if you have one, carefully spoon baking soda into the balloon until it's about halfway full. Without letting any baking soda fall into the bottle, carefully stretch the opening of the balloon over the mouth of the bottle. Hold the balloon upright so that the baking soda falls from the balloon into the bottle. Observe as the balloon inflates. What's happening? When baking soda and vinegar mix, they create a chemical reaction that produces carbon dioxide gas. This gas fills the bottle and then inflates the balloon attached to it. Section 5. Colorful chemistry with cabbage water. Red cabbage isn't just for eating, it can also be used as a pH indicator. This experiment will show you how the color of red cabbage juice changes depending on the acidity or alkalinity of different household solutions. You will need *red cabbage, a pot of boiling water *, a strainer, several clear glasses or jars, household liquids like vinegar, lemon juice, baking soda solution, soapy water, and plain water. Let's get started. 1. Chop the red cabbage into small pieces and place them in the pot of boiling water. 2. Let the cabbage boil for about 10 minutes or until the water turns a deep purple color. 3. Strain the cabbage juice into a separate container and let it cool. 4. Pour equal amounts of the cooled cabbage juice into the clear glasses or jars. 5. Add a small amount of each household liquid to a separate glass of cabbage juice. And 6. Observe the color changes. What's happening? Red cabbage juice contains a pigment called anthocyanin, which acts as a natural pH indicator. When it comes in contact with acidic solutions like vinegar or lemon juice, it turns red or pink. In the presence of alkaline solutions like baking soda solution, it turns blue or green. Neutral solutions like water will leave the cabbage juice purple. Section 6. Milk Masterpieces Swirling Colors You Can Create. This experiment is like magic, but it's really just science. Watch in amazement as colors dance and swirl in a dish of milk, creating your own mesmerizing masterpieces. You will need a shallow dish or plate, milk, whole milk works best, food coloring, various colors, dish soap, and a cotton swab. Let's get started. 1. Pour enough milk into the dish to cover the bottom. 2. Add a few drops of different food coloring near the center of the milk. Don't mix. 3. Dip the end of the cotton swab into the dish soap. 4. Gently touch the soapy end of the cotton swab to the surface of the milk in the center of the food coloring drops. 5. Watch the colors burst and swirl. What's happening? Milk is mostly water, but it also contains fats and proteins. Dish soap weakens the chemical bonds that hold these fats and proteins together. When you add the soap to the milk, it spreads out and grabs onto the fat molecules, causing them to move and create swirling patterns. The food coloring gets caught in the movement, creating a mesmerizing display of color. Section 7. Crystal Gardens. Growing sparkling structures. This experiment teaches you about crystal formation and patience. Grow your own beautiful crystal gardens with just a few simple ingredients. You will need Epsom salt, magnesium sulfate, hot water, clear jars or glasses, food coloring, optional, and glitter or small trinkets, optional. Let's get started. 1. Heat water until it's almost boiling. 2. Pour the hot water into the jars, filling them about 2/3 full. 3. Stir in Epsom salt, a spoonful at a time, until no more salt dissolves. 4. If desired, add a few drops of food coloring to each jar. 5. You can also add a sprinkle of glitter or drop in a small trinket for a more magical crystal garden. 6. Place the jars in a safe spot and let them sit undisturbed for several hours or overnight. 7. Observe the sparkling crystal formations that have grown. What's happening? Epsom salt is a type of salt that forms crystals when dissolved in water and then allowed to evaporate. As the water evaporates, the salt molecules come closer together and form a crystal lattice structure. The food coloring and glitter get incorporated into this structure, creating colorful and sparkly crystals. Section 8. The science behind the fun. These experiments aren't just about the wow factor, they're about understanding the fundamental principles of chemistry. By observing these reactions, you're witnessing things like chemical reactions. When baking soda and vinegar mix, they create a new substance, carbon dioxide gas, which causes the fizzing and inflating, density and buoyancy. The dancing raisins demonstrate how objects less dense than a liquid will float, while denser objects sink. pH and indicators. The color-changing cabbage juice shows how pH levels, acidity or alkalinity, can be measured using indicators. Surface tension and emulsions. The milk art experiment highlights the properties of surface tension and how soap can disrupt it, creating mesmerizing patterns. Crystallization. The crystal gardens demonstrate how dissolved substances can come out of solution and form solid crystals under certain conditions. Section 9. Stay curious and explore. Congratulations, young scientists. You've now conducted some amazing chemistry experiments using common household items. Remember, science is all around us, waiting to be discovered. Keep asking questions, experimenting, and exploring the world with your curious minds.